Today you're going to be doing binomial expansion. Now, the first example I'm going to do is going to maybe make you think, oh no, but I'll show you like the long way, then I'll show you the pattern that we notice as mathematicians. All right, so this is a binomial like x plus y or a plus b or x plus 4. I'm going to raise it to the 6th power, which seems innocent enough. Like I'm going to go x plus y times 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 x plus y. 1, 2, 3. Okay, so that's 6 of them. All right, so now I'm going to do FOIL with these two. So it gives me x squared. It's going to be xy and xy is 2xy plus y squared. And then instead of multiplying this one times this one, I know that this is also the same thing, x squared plus 2xy plus y squared. And I have another one of those, x squared plus 2xy plus y squared. Okay, all the while hoping I don't make a careless mistake. All right, now I'm going to multiply these two, and that gives me x to the 4th plus 2x cubed y plus x squared y squared. All right, now I'm going to do the middle one. Okay, so that gives me 2x cubed y, 4x squared y squared, 2xy cubed. Then I'm going to do this one, x squared y squared, 2xy cubed plus y to the 4th. All right, so let's let that sit there for a minute, and I still have to multiply it times this in a minute. Might as well see if we have some like terms. Let's see, I have an x to the 4th, x cubed y cubed. I think I have 4 of those. 4x cubed y, I mean. X squared y squared, I have 6 of those. I have 4 of these. And a y to the 4th. All right, now I'm going to multiply all of that times x squared plus 2xy plus y squared. You're starting to see why you would want like an easier way to do this. All right, so we're going to go x to the 4th times all of these, if we can keep up with that. All right, that gives me x to the 6th plus 2x to the 5th y plus x to the 4th y squared. All right, now I'm going to do, probably going to run out of colors. This one is going to give me 4x to the 5th y plus 6x to the 4th y squared. Got to go real slowly here. Hope I don't mess up. Plus 4x cubed y cubed. I think I'll stay with this color. This gives me 6x to the 4th y squared. Gives me 12x cubed y cubed. And 6x squared y to the 4th. And when I do this in the classroom, of course, it takes up a whole whiteboard. All right, this is plus 4x cubed y cubed. This is 8x squared y to the 4th. And this is 4x y to the 5th. This last one is x squared y to the 4th plus 2x y to the 5th plus y to the 6th. Wow, okay. So now I have x to the 6th. All right, I have 2x to the 5th y, 4x to the 5th y. And I think that's all of them. So that's 6x to the 5th y. X to the 4th y squared. This is 7 of them. That is 13. And I think I should have another one if I did this right. X to the 4th y squared. All right, so we'll write that down for now. All right, then I have, because this was 1, 7, 6. Okay, so now I have 4x cubed y cubed. 12, that's 16, and 4 is 20. All right, then I have x squared y to the 4th, and x squared y to the 4th, and x squared y to the 4th. So that's 6, and 8 is 14, and 1 is 15, which actually should have been what that number is. I don't know what I missed. Maybe somebody caught it. Then I have 6, x y to the 5th, plus y to the 6th. All right, so this one should be 15 right here. So x to the 4th y squared, x to the 4th y squared, and x to the 4th y squared. I don't know where I missed that. Let's see, this is x to the 4th y squared. This is where I missed it, right here. Let's see, I don't know what color I can do it in. I'll do it in red. This one right here, 4 times 2 is 8, x to the 4th y squared. So this one should have been an 8, which makes this one a 15. All right, now that was really tedious, but what did we notice if I did x plus y to the 6th? What's the tricky way to do it? Notice when you do a binomial to the 6th power, you end up with 1, 2, 3, 4, 5, 6, 7. If I do x plus y squared, I'm going to end up with 3. So it's always one more than this. This one's x squared plus 2xy plus y squared. So you end up with 3. So if I have like a plus b to the 4th, I'm going to end up with 5 terms. All right, so how do we do it the easy way? Some things that we notice is our exponents. 5 and 1 add up to 6. 4 and 2 add up to 6. 3 and 3 add up to 6. 2 and 4 add up to 6. 1 and 5 add up to 6. So our exponents add up to this 6 right here. Here are our exponents when we're squaring. This is 2. A 1 and a 1 adds up to 2, and this is 2. So I would expect that to happen. So what are we going to do? The easy way is this. Now I'll write them vertically at first because I run out of room. All right, so I'm going to go x to the 6th. And then I'm going to, oh, I'm sorry. Another thing we notice is these descend. X to the 6th, x to the 5th, 4, 3, 2, 1, and then no x at all. So I'm going to go x to the 5, x6, start with this number, 6, 5, 4, 3, 2, 1, and then x to the 0. So you'll have 7 of them. The y starts out with y to the 0, and then you have y to the 1st, 2nd, that's a 3, you can hardly see it, 4, 5, 6. So while the x's descend, the y's ascend, they grow. Y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, y to the 5th, y to the 6th, or whatever is in these positions does that. Now we need our coefficients. All right, some people get it from Pascal's triangle, which we'll go over, but I do it with something called combinations. The first one and the last one will always be 1, and so that's easy. All right, and then the next ones are going to be this number 6. Okay, but I'll talk about that. I'll start to build it. So what happens is you take this number 6 and put it over these two factorials. 5 factorial times 1 factorial. That's 6, 5, 4, 3, 2, 1. Cancel out with this 5, 4, 3, 2, 1, and just leave you 6. I guess I'll do that a little bit slower the first time. 6, 5, 4, 3, 2, 1 over 5, 4, 3, 2, 1. And it just leaves you 6. Okay. So this one is going to be 6 factorial over 5 factorial, 1 factorial, which is 6. And how you cut down on time is the symmetry of this. This is going to be 6 factorial over 1 factorial, 5 factorial, same result. All right, this one's going to be 6 factorial over your predetermined exponents, 4 factorial, 2 factorial. Here I have 6, 5, 4, 3, 2, 1 cancels, over 2, 1. 2 goes into 6 3 times, so I get 15. And this one's going to be the same. 6 factorial over 2 factorial, 4 factorial. It's going to be 6, 5, 4, 3, 2, 1. That's going to give me 15. And then this one is going to be 6 factorial over 3 factorial, 3 factorial. This is going to be 6, 5, 4, 3, 2, 1 cancels out over 3, 2, 1, and that gives me 20. All right, now if I write it down, I have 1x to the 6th. Here because y to the 0 is 1. Here I have 6 x to the 5th y. Here I have 15 x to the 4th y squared. Here I have 20 x cubed y cubed. Here I have 15 x squared y to the 4th. Here I have 6x y to the 5th. And here I have y to the 6th. Far easier than doing all of this other work up here. You can go straight to it. This is called the binomial theorem. This is the binomial theorem. Now, when you look at the binomial theorem, it's a really ugly looking formula with a bunch of like notation in it. Like for instance, this notation, you'll see it like this, C63, or sometimes you'll see it like this. Well, let's start with how our book does it. What this means is a combination of 6 things 3 at a time, which we'll study later. But if you just see this notation in your homework, this means to take 6 factorial over 6 minus 3 factorial, and then repeat this number 3 factorial. It gives you 6 factorial over 3 factorial, 3 factorial, which I believe gave us 20. There's ways to type this in your calculator also that I might show you in another short video. So this is CNR. A lot of times we use NR for our notation. So this number goes on the top, n factorial. Then you say n minus r factorial and r factorial. We'll practice some more of those in a minute. Let's go and do one of these. Let's say I have a minus 2b to the 4th, and you've got to expand it. Now, hopefully on a test, you won't go a minus 2b times a minus 2b times a minus 2b times a minus 2b. Because you saw, I do it all, I do this math all the time. I even made a mistake being careful. And also it just takes too long. So first of all, let's do binomial expansion using the binomial theorem. You want to always have this as plus. So you need to know what is in your first spot and your second spot. All right, so let's write this down. So this is my first spot, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, all the way down. The other one's going to grow. It's going to ascend. So bring your negative in, negative 2b to the 0, all the way up to 4. 1, 2, 3, 4. Then go back and take this exponent. Well, these are going to be 1s. And in fact, these are going to be 4s. But let's verify that. These are 4s because you're going to take 4 factorial over the exponents that you've already determined. 3 factorial, 1 factorial. So it gives you 4, 3, 2, 1. So that gives you 4. And this one would give you the same thing. All right, so we need this one. It's going to be 4 factorial over 2 factorial, 2 factorial. That gives you 4, 3. These cancel. 2, 1. Then you have 2, 1. That'll give you 6. Then you've got to carefully multiply this out. This is just a to the 4th right here because negative 2b to the 0 is 1. All right, this one, be careful, is a 4 times a cubed times negative 2b to the 1st. So this is going to be, I'll write it over here. 4a cubed times negative 2b is negative 8a cubed b. This one's going to be 6a squared times 4b squared is 24a squared b squared. This one's going to be 4a times negative 8b cubed. It's going to be negative 32ab cubed. And then this one is going to be just negative 2b to the 4th will be 16b to the 4th. So you see it alternates. A to the 4th minus 8a cubed b plus 24a squared b squared minus 32ab cubed. Sorry, I'm running out of room. Plus 16b to the 4th. Sorry, that's so ugly. I don't want to erase anything at this moment. All right, let's do one more. And there's some good examples in your book. All right, so suppose I have x plus y to the 5th. We'll make it x minus y to the 5th. So you have a minus. But whatever is in the front and whatever's in the back. So you do whatever's in the front, which right now is x. So it'll go 5, 4, 3, 2, 1, 0. The second one is plus a negative. So it'll be negative y to the 0, 1, 2, 3, 4. Stop at 5. Go back to this number and go 5 factorial. Well, the first ones are going to be 1. It ends up being that way anyway. These are going to be 5s. Okay. So now I just need my middle 2. So it'll go 5 factorial over 3 factorial, 2 factorial. It goes 5, 4, 3, 2, 1 over 2, 1. This gives me 10. All right, so let's see what this gives me. This gives me x to the 5th. This gives me minus 5x to the 4th y. Notice how these add up to 5. This gives me plus 10x cubed y squared. Notice how the exponents add up to 5. That gives me minus 10x squared y cubed. Gives me a positive 5x y to the 4th and ends with a minus y to the 5th. So notice here my lead coefficients on this one, as I worked them out, the 4th power, the first 2 will be 1s, and then these will be 4s. You maybe only have to figure out that one. All right, so if I have 3x minus 2y to the 3rd, that's going to be your first, well, you're going to make that plus a negative. So you're going to have 3x to the 3rd, 3x to the 2nd, 3x to the 1st, 3x to the 0. That 3 is going to impact your final answer. Then you have negative 2y to the 0, negative 2y to the 1st, negative 2y to the 2nd, negative 2y to the 3rd. Your first two numbers are going to be 1s, and then the next ones will end up being 3s. You can check it. Take the top, 3 factorial over 2 factorial, 1 factorial. Gives you 3, then 2, 1 cancels out, and so you get 3 for it. Both of these are the same thing. So on a grander scale, what if you had 3x minus 2y to the 8th? I would start off with 3x to the 8th, 3x quantity to the 7th, 3x to the 6th, 3x to the 5th, 3x to the 4th, 3x to the 3rd, 3x to the 2nd, 3x to the 1st, 3x to the 0. Should have 9 of them. 1, 2, 4, 6, 7, 8, 9. And then negative 2y to the 0, negative 2y to the 1st, negative 2y to the 2nd, negative 2y to the 3rd, negative 2y to the 4th, negative 2y to the 5th, negative 2y to the 6th, negative 2y to the 7th, negative 2y to the 8th. Got a lot of multiplication to do. What I was going to show you here is these are going to start off with 1s, and the next ones are going to be 8s. You could verify it. And so then you figure this one out would be 8 factorial over 6 factorial, 2 factorial. Once you figure that one out, it's going to be the same as this one because you have a 6 and a 2. This is 8, 7, 6, 5, 4, 3, 2, 1 over 2, 1. It's 56 over 2, which I think is 28. And then this one's going to be 8 factorial over 5 factorial, 3 factorial. This one's going to be the same thing. And this one's going to be 8 factorial over 4 factorial, 4 factorial. Now, granted, then you've got to get down, sit down and multiply all of these out. Like you've got to figure out 3 to the 6, negative 2 squared times 28. But it's far better than doing it the other way. You'll see later on real life application of this. All right, now, so homework, you're going to have some things. Let me look at the book real quickly. Say some good examples in the book. Okay, so you're going to have some of the C and R, or also sometimes it's just written in R. These are combinations, and people really do use this for real life, like probability. Remember, this is the first number factorial, subtract them, and then repeat the R. Same thing here. It's just two different notations for the same thing, like different ways to say division or whatever. These are called combinations. And this is what we're doing in front of our binomial expansion. So you have some in homework just to do, like 10, 3. You would say 10 factorial over 10 minus 3, 7 factorial. And then repeat this one, 3 factorial. So 10, 9, 8. That cancels. Over 3, 2, 1. Let's see. If I did that right, let's see, that should be 120. Also, it's fine with me if you do them on your calculator, but to me, they're a little easier to do by hand. Oh, by the way, you'll need to know 0 factorial. I think we've talked about this before, is defined to be 1. So if you have 8 and an 8, like in your book examples, you would have 8 factorial over 8 minus 8, which is 0 factorial. Repeat this. That gives you 1. And so much like we define certain things for an operating system, 0 factorial is defined to be 1. Also, it could be written like this. That notation is 7 factorial, 3 factorial, and then repeat the 4 factorial and figure that out. Great examples in your book. One more thing. And again, the examples are so good. They're doing it like this. Then they also go in and show you Pascal's triangle. Pascal's triangle goes like this. It starts with 1s. It's like a big tree. It's a Louis Pascal. You've heard of it maybe in Rapunzel. I think with the, whatever that little thing was, a lizard. He figured out this triangle that has all sorts of great stuff in it. It's like a tree. You add these together and get 2. Keep spreading out your 1s. That gives you 3 and 3. Keep spreading out your 1s. That gives you 4 6, and 4. Spreading out your ones, that gives you 5, 10, 10, 5. Keep spreading out your ones. This one gives you 6, 15, 20, 15, 6. You don't put these little V marks in there. I'm just doing that to show you like what I'm doing. So if you raise something to the third power, you also could get your coefficients this way. If you raise something to the fifth power, you also could just pull your coefficients out of here instead of using combinations. But we'll talk about all of that in the next class.